Somewhere in the Arizona desert, there's a tiny house with no well, no water delivery truck, and no connection to any municipal water line. And yet, every single day, clean drinking water comes out of the tap. Where's it coming from? The roof. Not rainwater. There's barely any rain out there. The panels on that roof are pulling water directly out of the dry desert air itself, turning humidity into liquid, drinkable water using nothing but sunlight. This isn't a prototype stuck in a lab. This exact technology is already installed in homes, schools, and assisted living facilities in over 40 countries. And by the end of this video, you'll know exactly how it works, what it actually costs in 2026, and whether it could realistically replace a well or a water bill for a tiny house of your own. Stick around, because I'm also going to show you the honest catch that almost every ad for this technology conveniently leaves out. Welcome to Tiny Home Reveal. Discover hidden rooms, smart designs, and unbelievable tiny homes from around the world. Let's get started. Before we get into the tech, hit subscribe and tap the bell, because we cover genuinely useful home innovations like this every week, and you don't want to miss what's next. Alright, let's pull some water out of thin air. Let's start with something most people don't think about. There's a genuinely massive amount of water floating around us at all times, just as invisible vapor in the air. Engineers estimate the atmosphere holds somewhere around 3,100 cubic miles of water vapor globally, enough to nearly fill the Great Lakes. And it's constantly being replenished by the planet's natural water cycle. The technology we're talking about today, called atmospheric water generation, or AWG, exists to pull a tiny slice of that vapor out and turn it into something you can drink. There are two main ways this actually happens. The first, and more common, method uses standard refrigeration. Air gets pulled into the machine, cooled below its dew point, the exact temperature at which water vapor turns back into liquid, and the condensed water is then filtered and purified before it comes out of the tap. This is essentially the same principle behind a dehumidifier, except purpose-built with medical-grade filtration, so the output is actually safe to drink, which regular dehumidifier water is not, since dehumidifier coils often leach metals and bacteria into the water they collect. The second method is more elegant, and it's the one used by solar-powered rooftop panels. Instead of refrigeration, fans pull ambient air across a hygroscopic material, essentially a sponge-like substance that naturally attracts and holds water vapor. The same basic principle silica gel packets used to control moisture. Solar heat is then used to release the captured vapor into a concentrated stream, where it passively condenses into liquid water as it cools. The water is then run through ozone sterilization and given a dose of minerals for taste, so it doesn't just come out clean, it comes out actually pleasant to drink. Either way, the end result is the same: water that started completely clean, as opposed to river water, groundwater, or municipal supply, which typically starts contaminated and has to be cleaned afterward. This isn't theoretical. As of 2026, there's a real, competitive market of companies selling this technology, and the products break down into 3 distinct categories, depending on what you actually need. Category 1. Drinking water-only countertop units. These are small, plug-in devices that sit on a counter and produce somewhere between 1 and 10 gallons of water a day. Enough for drinking and cooking, but not for a shower or a washing machine. Brands like Watergen's Jenny, Ecolo Blue, and Cara Waterfall here typically price from around $1,500 to $6,000, with no installation required. Reviewers testing these units in 2026 note they need no plumbing at all. You just plug them in. Category 2. Whole home systems. These are the units that actually tie into a house's existing plumbing and can supply every fixture. Sinks, showers, laundry, all of it. The 2 leading whole home options this year are the Aquaria HydroPack and the Genesis Systems WaterCube 100, both capable of producing over 100 gallons per day under favorable humidity conditions. But the price reflects that scale. The unit itself typically runs $14,000 to $35,000, plus another $10,000 to $25,000 for installation, depending on the electrical work and plumbing involved. That's a serious investment, often comparable to, or more than, drilling a brand new well. Category 3. Fully off-grid solar hydropanels. and this is genuinely the most elegant option for a tiny house specifically. Source hydropanels, made by a company called Zero Mass Water out of Scottsdale, Arizona, look almost exactly like a standard solar panel, except instead of producing electricity, each one produces roughly 3 to 5 liters of water a day, using only sunlight and air. No electrical hookup required at all. A single panel is about 8 feet long, 4 feet wide, and under 9 inches tall, and it can be mounted directly on a roof. Because the system doesn't tie into a building's structure or utilities, in most places it doesn't even require a standard building permit. Pricing has typically run around $2,000 to $2,500 per panel, plus a few $100s for installation, and multiple panels are simply added to an array to scale up production for more people. This technology isn't a lab curiosity either. It's already deployed at scale. Source hydropanel arrays are currently operating in more than 40 countries, and in the United States, a separate atmospheric water generator built by retired Army Captain Moses West is currently supplying drinking water at an assisted living facility in Jackson, Mississippi, addressing a genuine, long-standing local water quality problem for elderly and disabled residents there. Now let's get honest about the numbers, because this is where most videos on this topic get vague, and I want to give you the real picture for 2026. 4 whole home systems. Industry cost breakdowns aimed specifically at homeowners this year frame it like this. If you're facing a quote of $50,000 to $100,000 just to drill a new well, which is a real, common situation in parts of Texas, the Florida Gulf Coast, and California Central Valley, a whole home atmospheric water generator suddenly looks a lot more reasonable by comparison, even at $25,000 to $60,000 installed. But if you're already on cheap, reliable municipal water with no resilience concerns, industry analysts are surprisingly blunt. An AWG is simply not the right purchase for you. Full stop. Running costs matter too. Countertop and mid-size AWG units typically draw 300 to 850 watts during active production, adding somewhere between $30 and $80 a month to an electricity bill, plus another $140 to $200 a year in replacement filters, putting total annual operating costs in the $500 to $1,200 range for a household relying on one. Solar hydropanels sidestep the electricity cost entirely, since they run purely on sunlight, but the trade-off is lower daily output per unit, a few liters per panel per day, rather than dozens of gallons. And here's a genuinely important detail almost every ad glosses over. Humidity is everything. Most consumer AWGs are designed around at least 35 to 40% relative humidity and become noticeably less efficient below that. The most advanced units on the market this year claim to keep functioning down to as low as 5 to 7% relative humidity using desiccant wheel or hygroscopic material technology. Genuinely impressive engineering. But that's very much the high end of what's available, not the baseline. If you live somewhere with consistently low humidity, you need to specifically shop for a unit engineered for that, or expect meaningfully reduced output. So let's bring this back to the tiny house angle specifically, because scale changes the math here in a genuinely useful way, just like it did with self-cleaning tech in a previous video. A tiny house typically houses 1 or 2 people, which lines up almost perfectly with what a modest AWG setup is built to provide. You don't need a 100-gallon per day whole home unit built for a 5-bathroom house. A couple of countertop units, or 2 to 4 solar hydropanels, can realistically cover all the drinking and cooking water for a small household at a fraction of the cost of the industrial scale systems. The smartest approach for an actual off-grid tiny house isn't relying on atmospheric water generation alone. It's combining it with rainwater harvesting. Rainwater catchment systems, collecting runoff from the roof into a storage tank, are cheap, simple, and already common in tiny house and off-grid builds, and they handle the bulk volume needs, showering, dishes, laundry, flushing, extremely well in any climate that gets regular rain. Atmospheric water generation then fills the specific gap rainwater struggles with consistent, guaranteed drinking water, even during a dry spell with zero rainfall, since it only needs humidity in the air, not actual precipitation. Pair a rooftop rainwater catchment system with 2 or 3 solar hydropanels, and you get a tiny house that produces both its bulk water and its drinking water without ever needing a well, a water delivery truck, or municipal hookup. genuinely closing the loop on one of the last major utilities a fully off-grid tiny house still typically depends on outside sources for. Now, because this channel doesn't sugarcoat things, let's go through what actually holds this technology back, because every serious source on this topic circles back to the same handful of caveats. It's genuinely humidity and sunlight dependent. Solar hydropanels need consistent daily sun exposure to function, and both hydropanels and refrigeration-based units produce measurably less water as ambient humidity drops. If you're in a consistently cloudy climate or a genuinely bone-dry desert without a low humidity rated unit, real-world output can fall well short of the manufacturer's best-case numbers. Freezing temperatures are a real problem. Most hydropanel systems are only recommended for locations without prolonged hard freezes. When temperatures drop to freezing, the system simply enters hibernation mode and stops producing or delivering water until temperatures rise again. That's a genuine limitation for anyone in a cold climate expecting year-round output. It's not a full water solution on its own. Even the biggest whole home units, producing over 100 gallons a day, are engineered to supplement or replace a well or municipal line, not necessarily to cover every conceivable use without any consideration of household demand. And a single solar hydropanel, at 3 to 5 liters a day, realistically covers drinking water for one person. Not a shower, not laundry, not dishes. The upfront cost is real, and it isn't for everyone. Whole home systems, all in with installation, can run $25,000 to $60,000, genuinely comparable to drilling a well, not a cheap add-on. Industry analysts reviewing this technology this year are refreshingly honest about this. For a household already on reliable, affordable municipal water, the math simply doesn't make sense yet. And quality control varies a lot by brand. Because dehumidifier-style condensation alone isn't safe to drink, some DIY builders online have tried pairing a standard dehumidifier with an aftermarket reverse osmosis filter for around $1,500. And while that can technically work, it lacks the safety certifications, tested water quality, and reliability of a purpose-built AWG system. None of this erases what's genuinely impressive here. It just means makes its own water in 2026 usually means makes its own drinking water reliably as one part of a broader system, not a single magic box that replaces every drop of water a household ever needs. So here's where this actually lands. The idea of a house making its own water out of thin air sounds like science fiction, but it's genuinely real, commercially available right now, and already deployed in over 40 countries. From a zero-mass water hydropanel array quietly producing drinking water in the Arizona desert, to an atmosphere generator supplying an assisted living facility in Jackson, Mississippi that had struggled with water quality for years. For a tiny house specifically, the smartest version of this isn't one single miracle device. It's a rainwater catchment system handling the bulk of daily water use, paired with a couple of solar hydropanels, quietly guaranteeing clean drinking water regardless of how dry the season gets. Genuinely closing the loop on one of the last utilities most off-grid builds still depend on the outside world for. If this taught you something new today, subscribe. We cover real, buildable home innovations like this every single week, and you don't want to miss the next one. And I want to know, if you were building an off-grid tiny house today, would you actually trust water pulled from the air, or does a traditional well still feel safer to you? Tell me in the comments. I read every one. See you in the next video.